Check this out. Isn't that awesome? That is hydrodynamic levitation. Check it out. This styrofoam ball is levitating on this stream of water, and it's doing so in a very stable way. The setup is so stable you can play frisbee through it. Which is weird to me because the water is off to one side of the ball, and that doesn't seem to make any sense. You can block the water for a second, and the ball will still levitate. Have a look. Isn't that cool? How can it be stable like this? How can this be a stable configuration? That is what we're going to explain.
Cool, isn't it? Though in the video it's called hydrolevitation, the phenomenon pertains to the concept of equilibrium through laws such as the Bernoulli effect and Newton's third law of motion. Equilibrium in physics is a state in which an object doesn't change motion or energy over time. When an object is in equilibrium, it doesn't accelerate in a linear or angular direction. In other words, equilibrium is a state of balance. For example, the Bernoulli effect can be seen through a ping pong ball when placed into a stream of air. The ping pong ball tends to follow the stream of air, staying in the center of the stream in equilibrium. The ball appears to be floating because the air is being blown against the bottom of the ball, counteracting the force of gravity, basically lift. Whenever the ball drifts too far to one side, Bernoulli's principle goes into effect. If the ball is moved to one side, the distance the air has to move is increased, speed is decreased, and pressure is increased. Basically, with this higher pressure, the air molecules hit against the ball harder, realigning it. Due to this, the ball drifts back to the middle of the stream to be back in a state of equilibrium. This effect is present with a smaller ball and slower stream of air. However, with the larger styrofoam ball, another effect is the culprit. As the stream of water hits the ball, the water molecules grab onto the ball due to adhesion. This is a property of water to latch onto the molecules of both other materials and even water itself. As the water stays attached, it causes the ball to rotate away from the stream. This is where Newton's third law of motion comes into play. According to Newton's third law, every action has an equal and opposite reaction. Remember how the stream of water pushed the ball away from the stream? Well, the ball, in return, has a force which pushes itself toward the stream. These two forces cancel out, creating an equilibrium. Bernoulli's principle and these concepts about pressure make up the basics of fluid mechanics, which can be used to explain how planes fly, how water flows through pipes, or how a ping pong ball can seem to levitate in midair.